So good afternoon students. See, in the last 3 classes, right, we have discussed regarding 15 group elements, physical properties over, chemical properties over, and anomalous properties of nitrogen, right. Even I completed in the last previous class dinitrogen, compounds of dinitrogen, then nitrogen. Even I also completed ammonia, Haber's process, and even physical and chemical properties, right? Okay. Even I completed oxides of nitrogen also. That is N2O, laughing gas, nitrous oxide, nitric oxide, NO, dinitrogen trioxide, N2O3, dinitrogen tetraoxide, N2O4, nitrogen dioxide, NO2, and lastly N2O5, dinitrogen pentoxide. Okay, right. Now in continuation, according to your deleted NCERT syllabus, nitric acid. Okay, nitric acid and its property is there. Afterwards, phosphorus, all compounds have been deleted for theory purpose only, not for need purpose. For need purpose, compulsory you have to read it. There is no any way. Okay, right. That means just this theory purpose only I will complete nitric acid. Then we will go for 16 group. But we'll cover this at the last when we deal with the CET. Okay, right. So in this today's class I will tell you regarding nitric acid, another last compound of the nitrogen. Until now I studied oxides of nitrogen. Now today oxoacids of nitrogen. Oxoacids of nitrogen. Oxoacids, I am telling you, oxoacids of nitrogen. These are. What are the oxoacids of nitrogen? Oxoacids of nitrogen are number 1. Okay, that is hyponitrous acid. Hyponitrous acid oxides H2 N2 O2. Then second, nitrous acid. HNO2. Okay. Then nitric acid. HNO3. Then even peroxonitric acid. Peroxonitric acid that is HNO. Out of these oxoacids, we will study only one example, that is what? Nitric acid. Okay, what are the structures? Structure of this H2 N2 O2 are generally N double bond N, OH and OH. Right? This is structure of hyponitrous acid. Like this nitrous acid, NOH double bond O. This is nitrous. And nitric acid, N, okay, double bond O, double bond O, and yes, this is nitric acid, right? HNO3, this is nitric acid. Lastly, peroxonitric acid is totally different. N, O, H, this is peroxyl cage. Once again, double bond O, single bond. Right? This is how you can just have a glance of this. Right? Even that means here, if you write structurally in Lewis dot formula, it will be like this. Even this one. Right? Nitrogen on octet. In 2, 4, 6, 8, 2, 4, 6. That means we are having 1, 1, 1, electron. Like this here also. Okay, here also same thing. 2, 4, 6, 2, 4, nitrogen blue red. This is already nitrogen. Okay. Here also same thing. 1, 2, 3, 4, over 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 2, 4, 6. Hydrogen is blue. These are the Lewis dot formula or structures of oxoacids of nitrogen, that is hyponitrous acid, nitrous acid, nitric acid and peroxynitric acid. These are called as what? Oxoacids of nitrogen. Okay. Yesterday what you studied, oxides of nitrogen, and these are called oxoacids of nitrogen. Generally in the books they are not given clear. Please remember. Okay. Right. Now this detail we will study with what? Nitric acid. Our aim is to study in detail nitric acid, not this. But these are important for CET and NEET purpose. That's why I discussed with you with the structures, Lewis dot structures, not what you studied last year in chemical bonding. Okay? Right. So not much wasting the time. I will take you to the preparation part of nitric acid. How nitric acid is prepared in the laboratory. Method of preparation. Method of preparation of nitric acid, HNO3, lab method. See, in the laboratory, this nitric acid is prepared by treating sodium or potassium nitrate salt, NaNO3 or KNO3, along with the concentrated sulfuric acid. If you just heat it, so what you will get? Okay, we get our direct product, nitric acid, HNO3 plus NaHSO, sodium bisulfate. Okay. Further, even if you take NaHSO4 and react with H2SO4, you will get a same nitric acid but sodium sulfate. This is more than enough. This is how we can prepare nitric acid here in the laboratory. How it is prepared? By the reaction of sodium nitrate or potassium nitrate, KNO3 or NaNO3. Sodium nitrate, NaNO3 or potassium nitrate, KNO3, when they are treated with the acidic medium, concentrated sulfuric acid, you will get nitric acid along with sodium bisulfate. Okay? And this is simple lab method. But generally, on a large, that means industrially, commercially, you can prepare by using one of the important method called as Ostwald's process. Manufacture of nitric acid by Ostwald process, which is very important for theory purpose, once again for 3 marks. Either Haber's process or this Ostwald process is compulsory for theory examination for 3 marks. Let us discuss what is this Ostwald's process. See, the first process, that is Ostwald's process of manufacture of nitric acid. Ostwald process of manufacture of nitric acid. See, there are 3 steps are there. First step, oxidation of ammonium to nitric oxide. Ammonia is a gas, okay? It is treated with oxygen in the presence of platinum rhodium catalyst. It is about under 9 bar pressure. It is about 500 Kelvin temperature. Under this, ammonia is oxidized to nitric oxide, NO, and liberates water, H2O. Right? Ammonia is oxidized to nitric oxide in the presence of platinum rhodium catalyst under the pressure 9 bar and at about 500 Kelvin temperature. Okay? Right. These conditions are very important, compulsory have to write and balance the equation. See, 4 moles of ammonia, 4 NH3, therefore 4 and 4. Okay, then particularly now oxygen you have to balance, right? 4 3s are 12 hydrogen atom, therefore 6 H2O. Right, then balance. Now 4 plus 6, that is 10, therefore 10 oxygen is 5. This is balance equation. That means first ammonia is oxidized to nitric oxide when undergoes when heated catalytic oxidation. Catalytic oxidation in the presence of platinum rhodium as a catalyst under 9 bar pressure heated to about 500 Kelvin temperature. You can convert ammonia is oxidized to first what? Nitric oxide, NO. Okay, this is first step. Then second step is oxidation of nitric oxide to nitrogen dioxide, NO2. Simple it is. Further, nitric oxide is highly susceptible for oxidation. It gets converted to nitrogen dioxide very easily. 2NO plus O2 giving 2NO. Simple oxidation it is. Third step, that is dissolution of NO2 in water. Okay, that means nitrogen dioxide further is absorbed where in water to form. It undergoes disproportion reaction to form nitric acid and nitric oxide. Right? So generally and this is 3NO and 2HNO3. Sorry, 2HNO3 because 3 nitrogen already are there. 2HNO3, 2 3 is 6 plus 1 7 and here 3 2 is 6 6 plus 1 7. Hydrogen is also balanced, oxygen is also balanced, nitrogen is also balanced. Like this, by 3 steps we can manufacture nitric acid on a large scale. Okay, first one, oxidation of ammonia to nitric oxide. Second, oxidation of nitric oxide to nitrogen dioxide, simple air oxidation. Third step, dissolution of nitrogen dioxide in water. That means this nitrogen dioxide is absorbed in water, dissolves in water and gets disproportionate to form nitric acid and nitric oxide. Nitric acid and nitric oxide. And here we have purify this nitric oxide, just is subjected to fractional distillation. We get 68% concentrated what? Nitric acid. This is called laboratory grade nitric acid. Whatever we use in the laboratory for practical purpose, that is 68% concentrated nitric acid. Further it is concentrated to further even 98% concentrated nitric acid. Okay, by further fractional distillation. And remember, if the concentration of nitric acid after this fractional distillation is above 86% and above, 86% concentrated and above is called fuming nitric acid. Remember, fuming nitric acid. What is fuming nitric acid? 86% and above concentrated nitric acid is called fuming nitric acid, which is highly reactive. Even you can also call 98% concentrated nitric acid is called fuming nitric acid. Okay, right. So that's about this particularly nitric acid. Now, this is the 3 steps. Compulsory you have to write these 3 steps along with the balance equations and explanation. This is important for 3 marks for theory. Explain the manufacture of nitric acid by post-malt process. Direct question. You have to write this. No chart diagram. Only 3 steps. Remember, particularly very importantly, these you have to write according to your NCERT textbook only. Don't change with others, any other higher examination, because for theory you have to compulsorily follow strictly NCERT textbook only. Right? Okay. This is about manufacture of nitric acid by post-malt process. Then, coming to next regarding physical properties as well as chemical properties. There are only 2 methods of preparation. One lab method, that is by using sodium nitrate. Another industrial or large scale commercially by post-malt process. And for 1 mark, if they can ask you name the catalyst used in the post-malt process. What is that? Platinum rhodium catalyst. Okay. 9 bar pressure, 500 Kelvin temperature. Okay. Now come to next physical property. Generally physical properties and chemical properties. Physical properties just have to go through, not so important. Physical and chemical properties together I will tell you. Physical and chemical properties. Already structure I given you in the first half only. That is the structure, right? Now physical properties. This nitric acid is a colorless viscous liquid with a high specific gravity of 1.04 grams per cubic centimeter. This 68% concentrated nitric acid is a lab grade, what we use in the laboratory. Above 86%, just now I told you, it is called a fuming nitric acid, highly concentrated nitric acid, right? Okay. Then this is soluble in water, highly soluble in water. Whenever you react with water, nitric acid dissolves in water and forms hydrogen ion H3O plus and nitrate, showing that it is acidic in the nature. It donates proton, it's a proton. Okay, right. Next, after this solubility, now reactivity, reaction with metals, which is very, very important. Reaction with metals, especially copper and zinc. Copper and zinc. 2 marks fixed question for theory and very, very important for NEET purpose. Let us see what is important just in the observe. First, see here reaction of concentrated nitric acid, especially concentrated nitric acid, acts as powerful oxidizing agent and its products depends upon its concentration, okay, and even temperature and even material used for the reaction. I repeat, the products of chemical reactions of the concentrated, this nitric acid depends on its concentration, whether it is dilute or concentrated, and also on temperature and even on the material used. That means sometimes some intermediate materials are used for chemical reaction. What are those? Let us see one by one. First, reaction of this nitric acid with the copper. How it reacts with the copper? See, copper reacts with nitric acid. See, that is what? Dilute nitric acid. Dilute nitric acid, dilute nitric acid, okay? See, copper reacts with the dilute nitric acid, not concentrated, it will form respective metal nitrate, CuNO3 taken twice, okay? Along with the respective nitrate, it also forms main important here. It will liberate nitric oxide along with the water, that is H2O, right? But the same copper, when it reacts with nitric acid with a concentrated medium, concentrated nitric acid, here same metal nitrate, copper nitrate, CuNO3 taken as plus only C, NO2, nitrogen dioxide is liberated along with the H2O. That is reddish brown fumes of nitrogen dioxide. That's the difference. One marks theory they may ask. If it is a dilute, it is nitric oxide. If it is a concentrated, it is a nitrogen dioxide. It is colorless, neutral gas. It is a highly reddish brown colored acidic gas. I told you already, oxides of nitrogen. Now balance the equation, the above one. Okay. Generally, 8 HNO3 if you multiply, to make nitrogen 8, multiply by 3, 6, 2 NO, nitrogen becomes 8. Lastly, hydrogen how many are there? 8 here, 4 H2. This is the balanced equation. So 3Cu plus 8 HNO3 gives 3CuNO3 taken twice plus NO, 2 NO plus 4 H2. Balanced equation. Now when you come to this, here also, see nitrogen 2 plus 1 3, just multiply here, it becomes 4, therefore 4 HNO3, right? This is balance equation for what? Copper. Reactivity of copper with the concentrated nitric acid and dilute nitric acid. That means dilute nitric acid reacts with copper and liberates nitric oxide with respect to metal nitrate solution, leaves green color residue, right? But the same copper dissolves in concentrated nitric acid and form respective copper nitrate, but this time it liberates reddish brown fumes of nitrogen dioxide. That's the difference. This is for separated 2 mass solution. The mass is dilute or concentrated. That's why I told you products depends upon the concentration, temperature and material. Okay, this is for copper. Same thing if you discuss with next zinc metal. Same dilute and concentrated. Zinc reacts with the nitric acid. Dilute nitric acid. Dilute. Okay. And form respective metal nitrate ZnNO3 taken twice plus, okay, that is dilute is N2O plus H2. So this time will form nitrous acid, nitrous laughing gas with the dilute nitric acid. But the same thing when dissolves in concentrated nitric acid, okay, here will form same zinc nitrate, same metal nitrate, no doubt, but it will give also same nitrogen dioxide, no change, plus H2O. That's a change. Okay. The balance equation. See, 3, that is 8, but to make it by tetrahedral 10HNO3, okay, to make nitrogen just 10, multiply by 4, 4 2s are 8, already 2 are there, 10, okay, then 4 Zn here, and lastly hydrogen, what is it, 10, okay, already here 5, no balance equation, right? So like this 4Zn plus 10HNO3 gives 4ZnNO3 taken twice and 2O plus H2O. This is what? Nitrous laughing gas, nitrous oxide. Whereas the above is nitric oxide in the copper. But concentrated they give both same reddish brown gas, no doubt, with respect to metal nitrate solutions. Okay, here also same thing. 4HNO3, 2NO2 plus 2H2O. Right? So that's about reactivity of metals. Reactivity of nitric acid, dilute and concentrated with the respective metals. Right? Definitely one question for 2 marks in theory. Very, very important for Karnataka CET and even for NEET purpose. So many times it is repeated in the Karnataka, especially byproducts. But for point to be noted, another point to be noted for CET. With very dilute, not only dilute, only the word, use the word very dilute nitric acid, then the product is ammonium nitrate, not these oxides, remember. Okay, with the zinc it is ammonium nitrate. Copper also same, ammonium nitrate will be the byproduct with a very dilute nitric acid. Okay, right. But apart from this, sir, then this nitric acid reacts with other metals definitely. Especially metals react with the dilute acids, mineral acids, liberates hydrogen effectively. But since it is containing nitrogen, it liberates nitrogen dioxide gas. That's why it cannot give hydrogen. Okay, right. So coming to the next fact, that is metals like aluminium, chromium and aluminium, whether they react or not. Metals like aluminium and chromium, it renders passive because they form thin film oxide layer which cannot allow them to react further. With concentrated nitric acid, aluminium, chromium, Okay, these metals they rendered passive. Why they rendered passive? They do not show reactivity because they form thin film oxide layer with the nitric acid. But these will react with the non-metals because I told you it acts as oxidizing agent as well as reducing agent. It is a powerful oxidizing agent and also at the same time reducing agent. It reacts with non-metal also. How it oxidizes non-metals and reduces itself, let us see with some examples. Okay. For thin converse, only zinc and copper, no other metals, please remember, right? And this is a purely for CET purpose, remember. Now, with the non-metals, especially non-metals, like carbon, not only carbon, even that is nitrogen, carbon, iodine, okay, sulfur and phosphorus. Let us see. First see the carbon non-metal. This will concentrated nitric acid reacts to form. It oxidizes carbon to carbon dioxide, CO2. A normal product is SO2. Byproduct along with the water, as you know. Like this, iodine also reacts concentrated helium and it will get oxidized to hydroiodic acid HiO3 plus here NO2, nitrogen dioxide plus H2. So carbon to carbon dioxide, we write 4HNO3, 2H2O, 2NO. So balanced equation, right? Sorry, not balanced equation, 4NO. Okay, that's a balanced equation, right? Means 0 2 plus 4, increase in oxidation number from plus 5 to it is plus 4. Definitely, that means increase in oxidation number, oxidizes carbon to carbon dioxide, reduces itself to nitrogen dioxide. Like that here also iodine 0 2 per iodic acid. Plus 5, 0 2 plus 5. And once again plus 5 to plus 4. Okay, that is reaction. Balance equation 10HNO3, 2HiO3, right? 10NO2 and 4H2. This is balanced equation for iodine, right? Iodine is oxidized to hydroiodic acid and it reduces itself to nitrogen dioxide. Like this, even it reacts with non-metal, oxidizes carbon to carbon dioxide, iodine to hydroiodic acid. Okay? Right. Like this, just we will go for two more examples, highly complicated, that is sulfur and phosphorus. High amount of number of atoms are used for balancing equation. Just I will show you that trick. Not trick, just by hit and trial method, not that side. Because by other electron method, you can easily balance this equation. You take now phosphorus with nitric acid. Okay, phosphorus is oxidized to, that's important, phosphoric acid. First you have to write the possible products, then itself to nitrogen dioxide, then water. Okay, since it is phosphorus in P4 state, so 4H3PO, right? That's what here 12, and if you multiply here by 20, then it will be 4H2O, definitely, and here 20. This will be a balanced equation. Okay, phosphorus is oxidized to phosphoric acid. Phosphoric acid. In the CET, there is no need to remember this or balance equation. Just phosphorus to phosphoric acid. P4 elemental state 0 to plus. Once again, plus or to plus, like this. And lastly, sulfur octadynamic state. Okay. The same here also. Sulfur is oxidized to sulfuric acid. H2SO4 plus NO2, that is NO2 plus H2O, that is water. Here also same thing, 8H2SO4, okay. Balance this, we need 48 NO2, 48 HNO3. So hydrogen 16 to make it 48, 16, 32 plus 16 will be 48. That is how to balance the equation. That's it. That means sulfur is to sulfuric acid, phosphorus to phosphoric acid. Like this elemental 0 plus 6 most stable and plus 4 and here plus 5. Like this here nitric acid acts as both oxidizing agent and reducing agent. So this completes one nitric acid also. Okay. That means in this nitric acid, just please try to remember students post-word process, important for 3 marks for theory purpose. Next, we'll go forward. Next, properties, reaction of nitric acid with copper and zinc. Either dilute or nitric acid definitely. Or for 1 marks, chromium and aluminium, they remain passive due to oxide formation. Right? Okay. And these are, just have to remember oxidized product for CET and NEET purpose. Carbon to carbon dioxide, iodine to periodic acid, sulfur to sulfuric acid, phosphorus to phosphoric acid. Simple. Okay? Right. But you have to learn in theory, only copper, zinc, no these reactions. Carbon, at the most, that is iodine will come, but no phosphorus, no sulfur. Purely for CET. Don't worry. Okay? Right. Now, last, according to you, I have deleted NCERT syllabus as I told, I am telling you very repeatedly, phosphorus compounds are deleted for theory purpose, but for NEET purpose, there is no another way you have to compulsory study it, because already they are given 20-21 NEET syllabus. Okay? So now, after this, directly we will go to oxoacids of the phosphorus they have given in the syllabus. White phosphorus, red phosphorus, electron forms, phosphine, phosphorus trichloride, phosphorus pentachloride have been deleted for theory purpose. That you have to read for NEET purpose. Okay? Right. Keeping in that mind, oxoacids of the phosphorus lastly, this will complete 15 group elements according to your deleted NCERT syllabus for only theory and repeating for annual theory examination. Okay? Then what are the oxoacids? Oxoacids of phosphorus. Their structure, the oxidation state is important, preparation not necessary. Okay? Right. Let us see. The oxoacids of the phosphorus are first one, hypophosphorus. Hypophosphorus acid. Formula is S3PO2. Oxidation state is +1. Remember, and structure is phosphorus at the center atom. Okay. 2 oxygen atom. It contains 1 double bonded oxygen atom, 2 pH bonds, and 1 OH bond. Okay, and this is monobasic acid. Remember, this was mono. Since it contains 1 POH bond, which is ionizable, this one monobasic. Next, phosphorus acid. Phosphorus acid. S3PO3, 1 oxygen atom in there. See, this you have to write according to Lewis dot formula. See, 1, 2, 3, 4, 5 bonds. Right? Okay, then And the number of oxygen atom increases. See, very simple. We will write here. Oxidation state here generally +3. Okay. +3. Now what is the structure? What is the structure? Phosphorus. One double bond compulsion. If one oxygen atom increases, that is replaced by OH bond. Only one pH bond. This is S3PO. Okay. And this is since two OH groups are there, dialysis. Very important for pH. Then third, phosphoric or orthophosphoric acid, that is S3PO4. Okay, oxidation state +1. Right? And here is very simple. Once again, one double bond OH, OH, OH. Very easy to remember. As the number of oxygen atom increases, see, pH bond increases, OH bond increases. So this is tri-basic. We will ask this for very important for theory purpose and for need purpose also. Okay, theory and need. Theory as well as need. Structure, oxidation state. Let me ask you anything regarding whether they are monobasic, dibasic, or tri-basic. Okay. These are lower acids, +1, +3, +1. But in higher oxidation state, they can also be existed as. Okay, let us see what are those. Pyrophosphorus acid. Please remember this. Okay, just in continuation. Lastly, just I will learn. Pyrophosphoric acid, that is fourth one. Pyrophosphorus acid, H4P2O5. Remember the example. There are two phosphorus atoms attached by one oxygen. Here, one double bond O, one double bond O. pH, POH, pH and POH. See, H4 and P2O5. And this is dibasic. Dibasic, and here oxidation state is once again -10 +4 and here is +3. Okay. Then the fifth one. After pyrophosphorus acid, they are given you a hypophosphoric acid. Hypophosphoric acid. H4P2O6 is even number. Very simple to remember. Here we will go here only P and P bond. Double bond OH, OH and OH. This also OH and this side double bond. This is pyrophosphoric acid. And lastly, sixth one, very important for heat and safety, pyrophosphoric acid. Phosphorus, that was H4P2O7. Now this is phosphoric H4P2O7. Here +4. Okay, and here it is again +1. Structure once again POP, double bond O, OH. This is also tetrabasic. OH, right? H4P2O7. 1, 2, 3, 4, 5, 6. Like this, I have to remember one by one. That means here phosphorus acid, phosphoric acid, hypophosphorus acid, and last one pyrophosphoric acid. These are for your theory. Rest other pyrophosphorus and hypophosphoric, that is for CET purpose. Okay. But see, in all these you are observing phosphorus atom is tetrahedrally surrounded by 4 atoms. 4 atoms. That means phosphorus is sp3 hybridized. This is the characteristics of these oxoacids. And you are observing in all these acids compulsory they contain double bond O, double bond P double bond O, PH bonds and POH bonds. Okay. And see, remember here the basicity depends upon, does not on the H plus hydrogen, pH bond. pH bond is non-ionizable, but POH bond is ionizable. Therefore, as the number of OH group increases, basicity increases. Basicity increases. Monobasic, dibasic, tribasic. Okay, hypophosphorus monobasic because it will dissociate from O minus H plus. Like that. OH is ionizable but not pH is ionizable. So, which contain pH bond, they are act as good reducing agents. Okay, and which contain this OH bond, they will dissociate and they will show basic acidic character. They are acidic nature, but they are showing the basic character. Monobasic acid containing one replaceable hydrogen atom. Dibasic 2, tribasic 3. That depends upon POH bond, not pH bond. Remember, if they contain pH bond, they are reducing agent. If they contain POH bond, they are ionizable. Right? But all are in all phosphorus atom is sp3 hybridized. Whether it is lower or higher oxidation state, these also acids of the phosphorus. Right? And lower oxidation state generally they will disproportionate to higher oxidation state. One such example I will give you. This is 3PO3 phosphorus acid can get disproportionate to H3PO4 and BH3. Disproportionate means just see here 3H3PO4 plus BH3. Yes, plus 5 2. Plus 3 to plus 5 and even to minus 3. Same element, plus 3 to plus 5, oxidation, increase in oxidation number, oxidation. Plus 3 to minus 3, decrease in oxidation number, reduction. Same element undergoes oxidation and reduction. This type of reactions are called as disproportionation reactions. That means lower oxidation state elements undergo disproportionate to higher oxidation state and becomes stable. Okay. So these are the properties of oxoacids of phosphorus. That means, so today I covered nitric acid completely, right? Then oxoacids of the phosphorus according to your now deleted COVID-19 deleted syllabus. Okay, COVID-19 deleted syllabus. Now 15 group elements is over. Next tomorrow's class in the lecture 5 I will go for 16 group elements. After 16 also there you will have one deletion, that is sulfur dioxide contact process. The rest is remaining. Then we will cover these parts at the last lecture. Okay. So bye. Thank you and enjoy the day. So good evening students.